Hello everyone. So this is the third video that we are going to talk about modern evidence of plate tectonics in. Okay? So there's only one lesson goal that I would like you to be able to do by the end of this video is that you should be able to describe how data of marine magnetic anomalies support the concept of seafloor spreading as well as plate tectonics. So at this point, you should know that the magnetic bar of the Earth is very dynamic. It has been very dynamic because, based on geological records, the Earth's magnetic field has undergone multiple reversals, in the past. So this figure right here, the top left figure that you are seeing right now, this figure shows how the current state of Earth's magnetic field looks like. And these black lines, they all represent magnetic dipoles, and they all come out of the southern pole region of the Earth, and then they go out, and then they go in again, back into the Earth in the northern pole region. So this is how it looks like for the today's Earth's magnetic field. So therefore, when we go out there and sample rocks and put them in the lab and trying to figure out the paleomagnetic direction of the rocks when they form, when they show the same direction, when the paleomagnetic direction of the rock um, shows the same direction as today's state of the Earth's magnetic field, then we would call it as normal polarity or positive anomaly. Okay. However, that's not always the case. Some other rocks completely shows a completely different and reverse pattern, and that will be called as reverse polarity or negative anomaly. A nice example would be from layers of lava flows in volcanoes, because volcanoes they typically or they constantly put new lava flows and new magmatic stuff out there to the surface, so we can actually go out there and sample these rocks. So, for example, if we take a look at the sample from this little white box here, they show several light gray and darker gray shades, right? So here it simply shows that sometimes the Earth's magnetic field has a reverse polarity, and then sometimes it has normal polarity, and it's been going on, flipping back and forth multiple times throughout the geologic time. Now, the same observation can also be done in on seafloor. Okay, the reason for this is because seafloor is made of volcanic rocks. I know we haven't really learned about volcanic rocks yet, but for now, they're made of the same stuff that we saw in volcanoes. Okay, that we saw in the previous figure. So seafloor is made of volcanic rocks, and they also record again. They record the Earth's magnetic field at the time they form. So we can actually run a tool called a magnetometer across the ocean and try to figure out the patterns of magnetic anomalies in the oceanic floor. So it turns out that it looks something like this. Sometimes it gives us a positive anomaly and then goes back to negative anomaly, and it goes back and forth just like this. Okay, and we can actually plot them on a map and create some sort of like striping patterns. Okay, so some people call them magnetic stripes, but I just want to let you know that these magnetic stripes are not visible with our naked eyes, but obviously we can do that. We can see them by using that tool right there, magnetometer. Okay. Um, Another important observation is that these magnetic anomalies that we see, the patterns of magnetic anomalies that we see across um, mid-ocean ridges are actually mirror images. Okay, so for example, if we take a look at this darker band right here, okay, by the way, these data right here coming from this little box right there near Greenland and Iceland. So again, if we observe these darker bands right over here, and then we observe another thin darker bands on the other side of the ridge axis, which is indicated by this dash red line over here, you can see that these two darker bands are located in the same distance to the ridge axis. Okay, so they are so that again indicates that they form they likely form right at the same time. In fact, if we go towards the ocean, towards the mid-ocean ridge, the seafloor actually gets younger and younger. So all of these observation tells us something about how marine magnetic anomalies relate to seafloor spreading, because first of all, it shows us that mid-ocean ridges are indeed sites where new oceanic crusts form, because again, as we go towards the mid-ocean ridges, the oceanic floor, the age of the oceanic floor becomes younger and younger. And the second one, um, all of these observations also suggest that the mid-ocean ridges are indeed sites for seafloor spreading, because these two oceanic plates are moving away from each other. It actually allows the asthenosphere, the materials from the asthenosphere, to come out and create new rocks on the surface. Okay, I think that's all that I would like to say in this video. If you do have questions, let me know, and I'll see you next time. Bye bye.